In this lesson, we are going to be talking about doing the derivative of an exponential. And so the rule on this is if you have an exponential, something to a power, and there's where your variable is. So the b is a known value, and this is your unknown. You do the derivative, it is going to be itself times the natural log of the base times the derivative of the exponent. Now, hold on a second. We talked about in the past your basic exponential with an e as a base. So how come this just turns into, when you do the derivative of e to the x, it's e to the x, it's itself times the derivative of the exponent, right? So I see that piece and that piece, but where's this natural log? So if you follow this property, and if you take this and do the actual full-on property, it is itself times the natural log of the base times the derivative of the exponent. Right, so what happens with this? This is the natural log of e. That is actually this situation right here, where the natural log has a base e of e, so it simplifies out and just becomes 1. So that goes away, and then you're left with e to the x times the derivative of the exponent. All right, so this is what we've done in the past, but really there was an extra little bit to it, but it never applied only because we've only dealt with exponentials with the base of e. So we're going to do other ones, right? So now we're going to be talking about exponentials that don't have a base e. And so you're just going to add that little piece to it and see whatever things you can simplify. So the derivative of that, so f prime of x, is going to be itself times the natural log of the base times the derivative of the exponent, which is 1. So simplify that out, not much we can do. We're just going to be left with, let's see, just 3 to the x times the natural log of 3. All right, so hopefully it doesn't get any trickier. If we are looking at this one, this is that 108 is just like a constant in front of something. So it's like when you're talking about the derivative of 2x squared, the power comes down and multiplies. So that 108 is just going to flow through. So if you're doing g of t, it's going to be 108 times the derivative of this. And so this, if you need to, just to kind of know that that is a 2 to the 1 over 12t, if it helps to write it out that way. Totally up to you. But when you do the derivative of this, it's going to be itself. So t over 12 times the natural log of the base times the derivative. So the derivative of that is just going to be 1/12. All right, so if we start to go through all of this and kind of clean it up, what can we put together, what can we not put together? We can take a 12th of 108. So those two pieces are going to go together. So a 12th of 108 is going to be a 9, and then times 2 to the t over 12 times the natural log of 2. And that is our derivative. All right, so the 108 really didn't do anything. It ended up just multiplying to that derivative of the exponent. All right, so these two look awful similar to each other, and they are not at all similar. So this is, you have your variables up here. So this is an exponential. This is not an exponential. This is an x raised to a power. So it could be x to the third, x to the fifth, right? So you bring your power down, and then we subtract 1 from it. But I don't know what, I mean, I know what pi is, but I can't really subtract 1, so that's the best that I can do with it. That's it. Versus this one is an exponential. So you are looking at applying this rule. So it's going to be itself times the natural log of the base times the derivative of the exponent, which is 1. So that simplifies out to pi times x, pi to the x times the natural log of pi. And then the last one. Last one is we have a chain rule actually going on. So it's not an exponential because your variable e is not a variable. So it's same idea. It's trying to look like it's an exponential, but it's really not. Your variable has a second power to it. That's not a variable. So we're going to apply the chain rule. So we're going to be doing the derivative of the outside, which is bringing the power down, x squared plus 4, and we're going to subtract a power. So just like pi, I can't really subtract 1 from it, so that's the best I can do. So that's the derivative of the outside times the derivative of the inside, which is 2x. So not really much else I can do, so I'll just put it together. 2e x, right? Because again, e is not an unknown, x is my unknown, so I'll kind of leave it at the end. And then times our x squared plus 4 raised to the e minus 1. All right, so that was doing derivatives of exponentials, especially when they have something other than a base of e.